All right, so what we are adding to this today, if you will find your notes, we're on page 77. We are adding vertical and horizontal shifts. Okay, this means the left, right, up, down shift that we're doing with this. Part of that then is starting what we will do next class, which is going to be working backwards from a graph in order to write an equation of one. Okay, and we'll talk about a little bit of that as well. Okay. All right, so we're adding to this vertical and horizontal shifts here. So from last class, we learned about A in both of these forms, which was your amplitude. Okay, remember amplitude, it could be a negative out there, but we always make amplitude the positive, right? The negative just gave us the reflection. The B, just like last class, helped us find the period of the function by doing 2 pi divided by B. So what you're going to see now is an addition of plus or minus h inside the parentheses. The h is your horizontal shift, which has another name in this format, just in trig functions. I really don't know why. It's kind of old school. But it can also be called phase shift. So if you see phase shift, that is the horizontal shift specifically. Okay? Vertical shift is your up and down, and that will be this last part, the K at the end, with all my arrows. Now, we are going to start off the exact same way we started last time. We're going to start by finding the amplitude and the new period. And I actually, like if you're a pen user, it might not be a great idea to start with pen on these because you really want to do the first 5 points in the first period, then shift them left, right, up, down from there. Okay? So that's exactly how we're going to approach question 1. Initially, I'm just looking for the 2 things that we did last class. We are looking for A. What is my A? 3. That is my amplitude. If you need a pencil, there's a couple in the basket on my desk. Normally, the B value came after the sign and before the X. What's the problem here with that? There's nothing there. If there is nothing there, what is the implied B value?
1.
The B value is 1, which means the period remains what? 2 pi. So before I ever deal with the horizontal and vertical shift, I'm doing the exact same thing I did last class. So this is a sine graph, and it's still in 0 to 2 pi. So that means I'm going to kind of draw myself my basic. It goes from a 0. This one has an amplitude of 3, so my max is up at 3. 0, minimum of -3, back to 0. So far, the only changes to my sine graph have been the change in the amplitude. Any issues with that? All right, now let's look at our horizontal and vertical shift. Horizontal shift is the one that is inside with the X. Now remember, the left-right shift, do you remember how this looks in transformations? Yeah. It's the opposite of what it looks like, right? So if it says plus pi over 2, what does it really mean? Left. You may either say L pi over 2, or if you want to write it as a minus, you can, but like you need to know which way it's actually going. So I actually kind of prefer writing L so that you tell me you're going left. The vertical shift comes at the very end, and the vertical shift is exactly what it looks like, which is plus 1. So I go up 1. I tend to write up or down or U or D or something like that. Now, that means that I'm going to take each of those 5 points and shift them left pi over 2 and up 1. Some of us, when we start doing the left and right shift, you may want to think about what pi over 2 is in terms of like blocks on there. So if pi over 6 is 1 block, how many blocks is pi over 2? 3. So that way, I'm really just taking each of these points and going left, 1, 2, 3, up 1. Left, 1, 2, 3, up 1. Left, 1, 2, 3, up 1. And so on for each of my 5 points. I then erase my original ones so that I only have my 5. Now, you do not have to draw this in, but sometimes I will. As soon as you do this up and down shift, the central axis of the graph has now moved. Like where everything else was always coming back to 0, this is now no longer coming back to 0. What is it coming back to every time? 1. Okay? So sometimes, and most times for me, and this will help you with writing equations too, I kind of draw in like a dotted line there. It is not required. It's certainly not required. You don't have to have that. I just like to have like a central location that my graph is coming back to every time. So that when I then continue my dots, if I continued my points, and I got to go in a different color now so that it actually looks like not my dotted line, I'm just counting then left 3 blocks and down to the minimum of -2. Left 3 blocks and back to my central axis. Left 3 blocks and up to my maximum. I might be able to fit one more point over here, back up to a max, and I just kind of fit this and I get my graph within my points here. Now, does any of that change my domain? Sorry, change the page. My domain is still all real numbers. Now this one, I really do wait till the very, very end to set my range, because with the change in amplitude, then combined with the up 1, this has really changed my range on my graph, right? What's the lowest y value this gets to? -2. Highest y value? 4. So there's not necessarily a rhyme or a reason to your range once you throw in the left, right, up, down stuff. Okay? How's that feel? Pretty good? Question?
If it was a negative 0 out front, would you flip it over the x first?
Yes. Yes, and we're going to see one like that. Good question. All right, let's do another one of those.
Okay, so in the same way as we did question number 1, we will start dealing with question number 2, very similar to how we did in the first lesson. The amplitude of that will be 2. The period we'll get from doing 2 pi divided by the b value, which is pi over 3. So we flip and multiply, which gives us a period of 6. So I'm going to begin with doing my cosine function, which goes from a max to a max within the period of 6. And this time my max is 2. And if you feel comfortable doing the reflection from the negative right here as well, you can do that. But I'm going to start with a max and end at a max of 2. In the middle, I'm going to have my min of -2. Directly between the first max and the min will be a 0. Directly between the second max and the min will also be a 0. Then we'll add in our horizontal and vertical shift. So with the +1, we moved left 1. With the vertical shift, we move down 2. And just be careful to count correctly on the graph because the x-axis is counting by halves and the y-axis is counting by 2s. So I'm going to take each point and move it left 1 and down 2. Left 1, down 2, and so on, until I have all 5 of my points. Oops, I forgot to do the reflection. So we do have to do the reflection first. So first I would reflect here. That max becomes a min. That min becomes a max, and so on. Then do my left 1, down 2. Left 1, down 2, and so on, until I have all 5 of my points. Again, if it makes you see the graph a little bit better, you can draw in your dotted line axis at -2 to show that that's kind of the central line of your graph now that you're always going to come back to. So now if I would like to add some points, I can go over 3 blocks and back up, left 3 blocks and back up, left 3 blocks and up to a maximum, left 3 blocks and back to my 0, and I might be able to fit one more minimum here and connect my dots. My domain of all my sine and cosine functions remains the same, with -infinity to infinity, or all real numbers. My range is, on this one, -4 to 0. All right, so we're going to look a little bit at writing an equation. And writing equations, we're going to start the exact same way we started graphing them, where we have an amplitude and a different period, but we don't have a horizontal and vertical shift. So the first question we ask ourselves on the graph like this is, would it be better written as a sine or a cosine function right now? And this one would be better written as a cosine function because it begins at a maximum. So you want it to look the most like the parent function, and that's what we're going to look at on this. I can tell the amplitude of the graph here is 2 because it's the height of the wave, And I can also count the period of the function by counting the distance from max to max. So because max to max is pi, the period is pi. And so we have to remember that the period is not the b value. So last class we talked about, we had a formula, period equals 2 pi divided by b. That formula can be reversed to find your b by taking 2 pi divided by the period. So this time, if my period is pi, and I take 2 pi divided by pi, I get a period of 2, which goes in front of the x. The amplitude of 2 goes out front. The only other adjustment you might make is putting a negative there if it was a reflection of a cosine graph instead of a normal cosine graph.
All right, so my first question on all of these right now is this better written as a sine or a cosine function? Sine. Good answer. For those that are wondering why, what is my reasoning on saying this is a good sine function?
Well, it starts at 0.
Yeah, it starts at 0 here in the middle. Now, it looks a little different than my normal sine graph, doesn't it? Yeah, how is it different than my normal sine graph?
It's going to the right.
Yeah, it goes down to the right rather than up. What does that usually mean in my equation?
Negative.
It's going to have a negative in it. That's where I see that reflection. My sine function usually starts at 0 and goes up first. This one starts at 0 and goes down first. That's going to be a negative out front. Now, what else goes out front? The a value. What is my amplitude of this one? 3. So then my sine function is going to start with a negative 3 because of the reflection. Next, I look for the period of the function. There are multiple ways to find the period of the function. You can count your way through one full sine rotation. Just because you're writing this as a sine, though, doesn't mean you can't count the distance between maximums. It's totally fine to do that. If that's what feels comfortable to you, you can always count maximum to maximum. What's the distance between those two maximums? 4. That is the period of the function. Now, that does not go directly into my equation. I need to use it to find the b value. How did we just talk about finding the b value? 2 pi over b gives me the period, so to find the b, I do 2 pi divided by the period. What's 2 pi divided by 4 going to give me? Pi over 2. I'm going to put that in front of my x as my b value. Okay. Any questions about where we got any of the pieces of that?
I'm a little confused on the, can you explain the period thing?
So the period of the function, you can either count maximum to maximum, minimum to minimum.
I get that.
No?
Yeah.
This part?
Yeah.
So that, I took 2 pi and divided by the period of 4. That reduced to pi over 2. Okay? So we made our best attempt at 5. What's our amplitude in 5? 4. Okay. So no matter what, we can find amplitude. How or where can we see the period of this function best? Yep. Maximum to maximum. What is the distance between those? 4 pi. So that means I go off to the side and I find my b by saying 2 pi divided by 4 pi. What happens to my pi's? They cancel and I get 1/2 as my b. We all okay so far? Now, we didn't discuss, but is this best written as a sine or a cosine?
Cosine.
Cosine, because it starts at a minimum. Now, normally cosine starts at a maximum, so this just means it's going to be a cosine function that starts with a negative. So I put the negative in the 4 out front. I also then, after the cosine, put the b, 1/2, with my x. Now, a couple of you have already noticed. Could you see this as a sine function that is shifted right or left? Yes, and we'll get there next class. Okay? So, next class, we're going to add on to this that you can write both a sine and a cosine function for every graph that you see. And there will not be just one answer.
That's it.
Okay? That is it for today. Okay? This is not the worst lesson in the world. Okay? Feel bad for 8th period because they get to do this one with the next one. because we ran out of time. Hey, they lost that A day, or the B day that we got dismissed early before 8th period. Yeah, they're behind everything. It's going to be great. So, anyway, that's our lesson for today. You have time to either do homework, or I think in this class, everyone here has taken the 6B test. So if you'd like to knock out those test corrections, we will give you the shot to do that.